Good af good afternoon. I'm going to allow a couple of minutes just to make sure everybody's joined, to save us stopping and starting. Well, I think that's enough. Well, again, good afternoon. It's my pleasure to welcome you to this webinar on the hot reality, living in a plus 50 degrees centigrade world. It's equally my pleasure to introduce our speaker, Dr. Tim Fox, who is an internationally recognised expert in climate change mitigation and adaptation. He has specialist knowledge of clean energy, sustainable cooling and cold chains, process engineering based industries and sustainable food systems. He is a chartered engineer and fellow of the Institute of Mechanical Engineers, and he has worked as an independent consultant operating at the intersection of science, engineering, policy, business and communications. Tim is experienced in working with international bodies such as the UN, the EU and national governments, including the UK, Europe, India, Africa and Japan. He is also experienced of industry, businesses, finance, academia, NGOs, press and the media and the wider public. If you could show the next slide, Tim. Just to let you know that this is being recorded and you will be able to see that on the IMechE website. And equally, if you've got any questions, can you please put them in the chat and your microphone will be muted. Over to you, Tim.
Thank you very much, Alan, and thank you very much to the audience for joining us this lunchtime here in the UK. Good morning, good evening, good afternoon to you, wherever you are joining us from in the world. I'm going to apologise at the outset for not putting my camera on while I give this presentation. Unfortunately, I had an accident recently, and my face has been cut and bruised, and I think it would provide a significant distraction from watching the slides and listening to the talk and the conversation that we'll be having immediately after the talk, which will be chaired by Dr. Layla Sayin. As Alan said, I'm a fellow of the Institution of Mechanical Engineers, where I have chaired a number of boards and committees over the years, and I'm currently chair of the working group on climate change adaptation, which is sort of the home of this piece of work from the IMechE's point of view. And I will talk a little bit more about that as we go through the presentation. I'm also a member of the Clean Cooling Network, which is the collaborator, co-sponsor, if you like, co-collaborator on this event. And I'll be referring to them quite a lot as we go through the event. So what am I going to talk about for the next 35 to 40 minutes? And then what are we going to have a conversation on afterwards? Well, I'm going to be talking about this report, The Hot Reality, Living in a Plus 50 Degrees C World, which is a report that I was very honoured to be the lead author on. and I'll be telling you a bit more about the project behind that report. And one of the co-authors, Dr. Leila Sain, is joining us in this webinar this afternoon. And the other co-author was Professor Toby Peters, and I'll say a bit more about Toby in a moment. I'm going to be saying something very early on about clean cooling because the solutions in the report focus very strongly on clean cooling, and I need to explain a little bit about what that is so that we all have the same understanding of that. Then I'm going to dive into bits of the report. The report's a huge piece of work, so I'm going to be a bit selective in the areas we look at, but I'm going to be looking at the impacts of heat and how we can adapt to that going forward. So, you know, we're looking at living in a considerably warmer world, and I'm going to be laying some of that background out before we dive into the actual impacts and how we might adapt to that. Of course, COP29 began yesterday in Baku, and I'll be giving you some pointers towards COP29 as to where this work is relevant and where the broader UNFCCC activities are relevant to this work. I'll be giving you some recommendations, drawing a few conclusions, and then we'll be having a discussion based on questions and answers that if you'd like to offer questions in the chat or in the Q&A function, we'll be building those into our conversation. So let's just step back and have a look at the hot reality. I mean, this is very familiar territory to us now. When I began this piece of work nearly 2 years ago, I actually thought it would be quite difficult to convince people that we were going to see the sort of temperatures that I would be talking about in the report. But the last 2 years have really taken away that barrier. So to start with, I think we're all familiar with last year, 2023, being the warmest year on record globally since the series of meteorological records began, and of course the year was characterized by a record-breaking summer in the Northern Hemisphere, with the globally the highest temperature ever recorded on Earth at 52.2 degrees C being recorded in China. And we also saw prolonged heat waves across the southern United States, Europe, southern Asia, with temperatures well into the 40s, and heat waves that just went on and on and on. And at the same time, simultaneous with that, in the southern hemisphere, who were experiencing their winter, Australia and South America were having record winters, and southern Africa, many of the countries in southern Africa were having a prolonged heat wave that was colloquially termed as extending summer to an all-year-round event. So as the year progressed, we saw between June and August of 2023, at one stage, 3.8 billion people, that's over half the world's population, exposed to extreme heat. And this was a significant global event. Then as we went into the Northern Hemisphere's winter, and through into the early spring in the Northern Hemisphere, again, we saw the same pattern emerging, and 2024 has not been any different. We had a very intense heat wave across Asia in the spring. We saw summer temperatures in India in May approaching 15 degrees C. And at one point in June, over 1,500 records were broken in simultaneous heat waves across 5 continents around the world. And indeed, that month was the 13th consecutive month in a run of monthly temperatures that broke the records for those particular months in all previous years. So it probably comes as no surprise to everybody as we enter COP29 this week that the World Meteorological Organization announced that 2024 was on track for being the hottest year ever, so breaking 2023 records. So, I mean, hard, I know, for us in the UK to accept that, given that we had a fairly wet and cool summer. But across the globe, the situation has really been quite different. So, you know, that's the hot reality of what we're facing now. And for us as engineers, and for the broader society, broader society of professionals, and indeed the wider public, the reality is that worldwide seasonal ambient temperatures are rising. So each month, the temperature that we experience in that month, compared with previous months in previous editions, if you like, of that month in the past, are getting hotter. So it's like the drip going into a tap. The overall sort of background temperature is going up, and heat waves are becoming more frequent, prolonged, and severe. And the second element of the reality really is that the current policy commitments that the policymaking community, governments worldwide, are committing to and implementing will not really help us in terms of mitigating that reality. So many of you will have seen that the United Nations Environment Programme, UNEP, published its emissions gap report, its annual emissions gap report, recently, about a week or so ago. And in that, they concluded that the world is on track with current policy settings to be at a 2.6 to 3.1 degrees C increase in global mean temperature compared with pre-industrial levels by the end of the century. So we're well off track for keeping to the Paris Agreement's 2 degrees and its aspiration of achieving 1.5 degrees. And in fact, I'm sure many of you will have seen in the news this week that the current projections are that this year, 2024, will be the first year ever where we exceed 1.5 degrees C annual global mean temperature compared with pre-industrial. So we're going to need to do something in terms of adaptation as well as mitigation. We can't stop our efforts in mitigation. We need to double down on those efforts, but we have to accept that we're going to have to undertake some serious adaptation and resilience capacity building to be able to cope with the sort of temperatures we're going to see around the world through to the end of the century. And clean cooling provision across multiple sectors is a critical component of that adaptation approach in enabling, without holding any punches, humans to survive on the planet, and indeed to thrive on the planet into the future. And it's vital that those of us that are within the the engineering community and its broader support ecosystem, ensure that clean cooling systems are well adapted and resilient to climate change. So we need to get our house in order, as well as offering clean cooling as an adaptation strategy. And this is the fundamental tenet of the report. The report makes the case for clean cooling as an adaptation strategy, and calls for its recognition as critical infrastructure. So let's have a few words about clean cooling. So clean cooling was originally conceptualized towards the end of the last decade, around about 2017, by the Centre of Sustainable Cooling, led by Professor Toby Peters. And it looks at cooling through a much broader sustainability lens than simply reducing emissions. It's about providing a cooling and an approach to cooling that simultaneously contributes towards reducing greenhouse gas emissions, whilst also undertaking natural resource conservation, offering air quality improvement, and enabling us to achieve a broad range of other sustainable development goals and aspirations. And it sits at the intersection, essentially, of the Paris Climate Agreement, the Kigali Amendment to the Montreal Protocol and the protocol itself, and the United Nations Sustainable Development Goals. So in a broader sense, to achieve these socio-economic and societal goals, it needs to be the technology and the approaches to cooling need to provide solutions that are accessible, affordable, financially sustainable, scalable, safe, and reliable. So it's no good producing a point solution to cooling that can't be scaled, or indeed isn't safe to use in all countries around the world, and it's not financially sustainable everywhere. And ultimately, it's about helping the global community in adapting and building resilience to the climate change impacts that we're going to see in the coming decades, whilst mitigating the adverse effects of those impacts and risks. So let's turn to the project itself. So the project was an 18-month-long project undertaken as part of a DEFRA-funded activity called Sustainable Cooling and Cold Chain Solutions, which is work that is being driven forward by Professor Toby Peters, who is the director of the Centre for Sustainable Cooling at the University of Birmingham. And it's important to recognise here the contribution that Toby makes to this topic. For many of you, you'll be familiar with his world-leading, future-focused, in terms of incumbent disruptive thinking, which really drives these agendas forward. The project involved a multidiscipline, multi-sector international team of over 35 individual contributors, but of course those contributors were supported by their much wider teams within their institutions, organizations, universities, industrial companies, etc. And indeed, the Institution of Mechanical Engineers contributed significantly to the work that went into this report. Several members, fellows of the institution and staff members were involved in the report, in addition to myself. And a lot of the work that we've done in this area over the last decade was included and integrated into the work. So the initial findings from the work were presented during last year's COP in Dubai. And the full report itself was launched in a collaborative event with the Institution of Mechanical Engineers on the July the 18th at IMechE's One Birdcage Walk headquarters in Westminster. And this event today marks our contribution to the COP29 discussion. So you can see here, I don't expect you to take in all of the contents on the on this screenshot of the contents page of the report, but you can see it's a fairly extensive report, very comprehensive, very detailed, very deep. So as deep as it is broad. So a huge, if you like, evidence base and source of material, a kind of state of the nation play on where we are on adapting to heat and the role of clean cooling in that. So the report focused on people, health and mortality, buildings and the built environment, food production, supply and security, health infrastructure, vaccines and medicines, and through into a broader range of workplaces and industries, and including digital infrastructure, and particularly the impact of AI energy demand on the requirement for cooling, broader sort of socio-economic impacts as a result of economic productivity changes, the technologies and approaches to cooling themselves, taking a broad systems thinking approach and thinking thermally when thinking about providing cooling, and then into areas of real sort of societal impact in terms of migration, the impact on refugees and refugee camps. You may have seen my IMechE blog about needing to undertake significant adaptation to refugee camps, which was published a couple of weeks ago. And then all of the ecosystem that supports these adaptation techniques and solutions. So funding, finance, business models, training skills and standards, and of course, policy making. But the way the report was structured was really looking at the impacts of heat on people, places, and the functioning of society, how we can adapt to those heat impacts, looking at individual sector-based and place-based adaptation solutions. So, as some of you joining us today will be aware, adaptation is very different to mitigation in that it's very place-based and very place specific in terms of its context. So the report puts a lot of focus on place-based solutions as well as sector-based solutions. But of course, when these place-based solutions are spatially integrated, they form a complex national and international infrastructure system in which we'll be undertaking adaptations that will affect billions of people across the globe. So the report is very sort of globally focused, but built on sector-based and place-based adaptation solutions. So I haven't got time to go into all those areas. We'll be here for the rest of the day. So I've just picked a few areas to quickly dive into, and I point you to the report if you're looking for much more detailed information on these particular issues and areas, subject matter areas. So on food production, supply, and security, I think one of the key things we have to understand is that the impact of these rising seasonal temperatures and the increasing frequency, length, and intensity of heat waves will have a fundamental implication for food and nutritional security around the world. Of course, food safety is of prime importance, and the effect of heat on the speed at which food rots will have a significant impact on our ability to manage and control food safety and the resulting health and livelihood impacts of that food deterioration, particularly, of course, in the global south, but with very strong implications in the global north. For example, many people probably don't realize how much a country like the UK is dependent on imports. Around 47% of vegetables and more than 84% of the fruit that we consume in the UK comes from outside our borders. So, things that are going on elsewhere in the world, potentially as a result of heat impacts, will have a significant implication for us. Shifting growing seasons, disrupted production schedules, and disrupted supply chains are all very much what we can expect and anticipate and need to manage and mitigate. On average, though, if we sort of step back, we will see an around 6 to 7% reduction in yield per 1 degree centigrade above a seasonal mean temperature in any particular location. So if you think certain places will go up, typically seasonally, their mean temperature may go up 4 or 5 degrees C, bearing in mind that we've been talking about global averages beforehand rather than place-based focused numbers. You can see that's going to have a significant impact potentially on yields. For example, we're anticipating that the maize production in East Africa will decline by around 32% in the period 2040 to 2070. And in certain parts of West Africa, we might see that decline by up to 85%. So it doesn't surprise us that overall global crop yields could reduce by up to 30% by 2050. And of course, while global crop yields are reducing, also animal productivity is reducing, both in terms of the biomass of the animals themselves and in terms of the production of milk and other dairy products from livestock farming. So again, we're anticipating to see, for example, in terms of animal biomass decline, a decline of around 5% per 1 degree of warming. So all this means that whatever we do produce, it's absolutely essential that makes its way to the marketplace in a safe and nutritious condition at an affordable price. So supply chains and the integrity of those supply chains, particularly those that have cooling within them, is going to become increasingly important as we go forward. Turning to the built environment, just a few stats I drew out of the report here to give you a sense of the sort of impacts we're likely to see. 90% of hospital buildings in England are vulnerable to overheating. Many people are just completely aware of that staggering statistic. So at a time when hospitals need to be taking in more and more patients as a result of heat stress during a heat wave, the hospital buildings themselves will be overheating, and indeed the areas that store the medicines within the hospital will be suffering overheating. If we turn to residential dwellings in a country like the UK, 55% of our bedrooms in residential dwellings in the UK would fail the overheating criteria today, let alone in a 2-degree world, where it would increase to 100% in such a scenario if we look towards the end of the century. And of course, I've just mentioned the UNEP emissions gap report that says we're well on target for exceeding that 2-degree limit. But of course, if we turn to developing economies of the world, we see heat stress within the built environment that way exceeds anything that we might expect in a country like the UK. And for example, in Calcutta, in India, summer indoor average 24-hour heat stress index in urban slums has been measured at up to nearly 5.3 degrees C higher than that recorded outside, where the temperatures are already at dangerous levels of above 45 degrees. For an average of nearly 9 hours during that same period. So the implications for this are widespread in terms of human health, mental health, and ability for people when they come home from work to be able to rest and get a good night's sleep before they go back to work the next day. So it has follow-on impacts for workplace productivity. Of course, all of this is exacerbated by the urban heat island effect, where the center of cities are much higher temperatures than the surrounding hinterland. And of course, ultimately, this leads to the tragedy of deaths. And in 1991 to 2018 period, 37% of heat-related deaths across 43 countries worldwide could be attributed to climate change-driven temperature rises. Now, not all of this, of course, is in the built environment, but a significant amount of it is. So often, when people are struggling with these temperatures, they're going to be turning towards cooling as a source of relief. At a time when, of course, stationary and mobile equipment will become increasingly stressed itself and suffer reduced performance and is more likely to fail. So as temperatures go up, we see the performance of the individual refrigeration systems and air conditioning systems reduce. And in fact, per 1 degree increase in the ambient temperature within which the equipment sits, typically refrigeration, air conditioning equipment loses about 1.5 to 2.5% of its performance. So the other thing we should be very cognizant is that even in a country like the UK, the current installed refrigeration equipment is typically designed for a maximum temperature of around 31 to 32 degrees C. It has very long replacement cycles, 20 to 30 plus years, and is increasingly subject to asset sweating across food supply chains and indeed the broader sort of cooling community. So we see, in terms of getting our house in order, the refrigeration industry and the engineering community in support of that has some significant challenges to address. Increased pressure on, of course, during these periods of intense heat will lead to limited technical support capacity being stretched, knock-on effect on routine maintenance, which then creates a kind of vicious cycle of more breakdowns leading to more call-outs, leading to less routine maintenance, etc. So, we as an engineering community need to understand that it's not just those heat waves that will have a significant impact. Higher seasonal ambience and increased air moisture holding capacity has an impact on the performance and reliability of machines over time through constant operation outside of their optimum design envelopes. And indeed, at times of stress, even here in the UK, there are anecdotal reports that up to 30 to 60 UK retail stores within large retailers experience whole system shutdowns within a matter of days when temperatures exceed system design boundaries. Because all of this has an impact on workplaces and economic productivity. Cumulatively, costs globally of extreme heat in 1992 to 2013 were estimated at between 16 and 50 trillion US dollars, primarily as a result of impacts on health, productivity, and agricultural output. But of course, this has a disproportional distribution around the world, with low-income regions suffering much greater than higher-income regions, with low-income regions losses are around 8% GDP per capita per year, whereas the wealthiest were averaging just around 3.5% during that period. Of course, there are injuries within the workplace that surge during periods of higher temperatures, and of course, we're more likely to see industrial action taking place across the world. So, turning to the solutions and what we can do about this. As I said, within the report itself, we look at sector-based and place-based solutions, as well as then moving outwards to look at systems-based solutions and bringing that all together in terms of cooling infrastructure. So in the food production and supply and security area, it's not all about providing cooling, of course. We can develop heat and drought resilient plants. We can provide early warning systems, better water management systems, and diversification of production. But in many cases, we will resort to deploying cooling indoors for indoor horticulture, farming, and aquaculture. And we already see across the Middle East, livestock being brought inside and dairy farming taking place inside large, cooled, and if you like, moisture-fed environments inside large warehouses. So cooling through the use of evaporation, through, if you like, shower systems, sprinkler systems, and mechanical cooling itself. As I said earlier, loss reduction is really important within the supply chain at the moment. Within the food supply chain, for example, around 13% of global produce is lost. Around 37% or thereabouts is wasted by consumers, food service outlets, and retail. But within the supply chain itself, around 13% losses because of lack of integrity in the supply chain. A lot of that is to do with perishable produce not entering a cold chain. So, as you know, we on average around the world, something like a third of food is estimated to be to not reach the consumer from the point of production. So we need to see, as we go forward, the bias towards investing in production rather than post-production being addressed. And in particular, we need to see the development of accessible, low-cost, clean cooling technology options and appropriate training programs and innovative funding and finance and business and policy programs for a better fit, particularly in the global south. In the built environment, it's really about rediscovering passive methods. So looking at the orientation, shading, reflective use of buildings, looking at reflective surfaces, green roofs and walls, cladding material, using thermal mass for cooling, capturing predominant breezes for natural ventilation, and the use of internal courtyards and cool water flowing through internal courtyards. Because a lot of this has been previously embodied in vernacular architecture, but has been lost in our quest for shiny glass boxes with no external incumbents on them, spoiling the look of them. So it's about rediscovering our knowledge and re-implementing that knowledge. And of course, the same applies for the wider built environment, where natural shading, water bodies, water courses, green spaces and corridors can add to the cooling of urban environments, better design of street airflows, use of different construction materials, and indeed, in cases where it is challenging to undertake those kind of interventions, to provide networks of cooling centers and external cool spaces. Because ultimately, in many cases, we have to resort to active systems, so mechanical-based energy-consuming equipment like air conditioners and refrigeration. And in those cases, we need to ensure that we improve their efficiency, so that they are the highest efficiency that can be attained. And we need really to look at mandatory high performance rather than minimum performance regulations. Of course, there's a big role for district cooling networks, which tap into natural water bodies and sources of waste cold that are unused in industrial processes, if you like, mimicking what we already understand through our work on heat networks, district heat networks. Turning our attention to the vaccines and medicines, we need to take a different approach to the way in which we distribute vaccines, a way in which we deliver them. It's clear that there's a role not only for improved cooling, because at the moment, many of you may not be aware, but 25% of vaccines are lost due to degradation within the supply chain between the point of manufacture to the point of administration to an arm or whatever, due to insufficient and inadequate cooling infrastructure in terms of a robust cold chain. But beyond that, we need to think about, beyond improving the cold chain itself, we need to be very cognizant that we need to think about future vaccine technology. So that means lipid enveloped mRNA, as we saw during the COVID pandemic, the move towards those kind of vaccines. And we need to look at a different approach to vaccination, rather than in many countries where the infrastructure is just not there to be able to support that mass vaccination programs in terms of the cold chain to move and store those vaccines within those territories and jurisdictions. We may want to be looking at the use of approaches based on individual point of care lateral flow test assessments of what the actual vaccination requirement is within a community, and then rapidly deliver the exact number of vaccines required for that community. So thinking about using drones, for example, reconfigurable infrastructure for these highly temperature sensitive vaccines. Many countries simply do not have that minus 20 degrees C cooling capacity, refrigeration capacity needed to support mRNA vaccines for mass vaccination programs. So we need a different approach there. Because with cooling equipment, we need to think about designing differently. So there's a role there for us engineers in terms of ensuring that the equipment is designed for the right operational temperatures, and that the equipment incorporates far more flexibility, and the systems incorporate far more flexibility to deal not only with the higher temperatures, but of course the wider range of weather impacts that we're going to see, extreme weather events such as storms and flooding, etc. So here in the UK, for example, in the 1980s, it was not unusual for supermarket refrigeration to be designed for a maximum temperature of 28 degrees C. And luckily for us, in many ways, in the 1990s and the 2000s, a move to more restrictive food safety regulation meant that design temperatures went up to 32 degrees as standard. But of course, now we're looking at a future where we need that temperature to move up, and it is moving up within standards to 35 degrees C. And some industrial players are taking it upon themselves to voluntarily design for 40 degrees C. So a lot we can do there in terms of design temperatures, but of course, as I said earlier, we need to be very cognizant of the replacement cycle within particularly the food sector for refrigeration equipment being very lengthy, and anything that is being installed now is going to potentially be there for 20 to 50 years. Of course, there's a lot we can do to the system itself in terms of reducing the cooling load, improving equipment and system specification, applying different system designs, revising the design of vehicle bodies, up and loading and unloading areas, and taking a different approach to the optimization of operation and put more emphasis on performance and less on initial cost when we're making the specification for procurement of new equipment. Of course, there's a role for better training and more focus on maintenance, and that's focusing very heavily on mechanical systems. But of course, there's a big role for the design of passive and nature-based solutions that can apply using different resources. And when we do that, when we use those natural resources, we have to be very cognizant, of course, of the local climate change that is going to take place that will impact the air, water temperature and quality in those local areas. So engineers need to be very cognizant of that. Because there's a role in terms of dealing with the workforce in terms of updating safety procedures and policies on occupational health, as well as collaborating with employees to co-design new working practices and strategies for dealing with heat stress. And this may involve rescheduling manufacturing to different times of the day, rescheduling production, installation, maintenance, change to core hours of work, etc. But there's a lot of work to be done there beyond the hardcore engineering of the kit itself. And of course, even wider than that, need for better training, wider skills development, and the updating of a very broad range of standards. And finally, I just want to say a few words about critical infrastructure. The report works towards building an evidence base and out of which a conclusion emerges where cooling infrastructure is very clearly part of a critical infrastructure of any particular country, particularly as we move forward into this hotter world. And the recognition of cooling assets, facilities and systems, networks and processes, and the people that support that, the whole ecosystem that supports that as critical infrastructure is vital for our ability to survive and thrive on the planet. Just a few final words that before I just address COP 29 and then close. If we don't do this in the absence of a whole of government multi-sector approach to cooling policy, which its designation, its recognition as critical infrastructure would enable us to do. If we don't do that, we'll be failing to lay the foundations for a well-adapted, climate resilience cooling provision for society, and create vulnerability, low national resilience to rising temperatures and more frequent severe heat waves. And this will translate into risks to services as vital as food, health, industrial, digital, all the sort of things that we look at within the report. So the stakes could not be higher, but the tangible outcomes and benefits are significant. So the potentially financial savings on investments, in other words, in otherwise unnecessarily electricity generation, power distribution, cold chain equipment, digital infrastructure, the freeing up of renewable energy resources for use in other infrastructure sectors instead of having to support cooling, increased resilience in energy, food, health and communications, transport, water and other critical national infrastructures, minimize deployment of mechanical cooling and therefore a better outlook for reducing our greenhouse gas emissions and meeting our commitments under the Paris Agreement, the Kigali Amendment and the Sustainable Development Goals. Just two moments on COP 29. Overall, the UNFCCC in the last decade or so have focused much more strongly than they did in the past on adaptation. In 2010, at COP 16 in Cancun, they established the Adaptation Committee, which oversees all of the UNFCCC's work on adaptation. And part of the mechanisms that were put in place to support the activities of that committee and nations around the world in terms of adapting, the Green Climate Fund incorporates an adaptation component from COP16 onwards. Countries, developing economies and least developed economies are encouraged to develop national adaptation plans. And indeed, there is a least developed countries expert group within the UNFCCC system. And there is a global goal on adaptation that was built into the Paris Agreement. And much of the adaptation work is underpinned by the United Arab Emirates Framework for Global Climate Resilience, which came in December 2023. So Look out for matters relating to adaptation in the COP29 agenda, the annual report of the Adaptation Committee, and the Green Climate Fund and the Least Developed Countries expert group are core elements of what we should be looking out for in terms of the relevance of this work to the process and indeed the COP itself. So just a couple of recommendations to close with. There are 43 recommendations in the report. I've just picked out the ones for government, which are very straightforward. Adopt clean cooling as an adaptation and resilience building strategy and build it into all the planning for adaptation and resilience. Recognise cooling is critical national infrastructure and designate it as such to give it the right level within policy making and develop and implement policy and market interventions that help with the existing disparities and divides between the global north and the global south. Effectively, recommendations for academia to support those activities and for industry to support those activities. So in conclusion, I think it will be clear from this quick trot through the report that cooling is vital to humans in surviving and thriving on this hotter planet. Deploying clean cooling offers an adaptation strategy, but if we're going to do that, we need to ensure that our house is in order and that the clean cooling solutions and approaches themselves are well adapted and resilient. And the report provides the evidence base through to that. So I'm going to hand over to Dr. Leila Sayin now, who from the Centre for Sustainable Cooling and the Clean Cooling Network, who's going to handle the Q&A. Leila.
I think first Alan.
Alan, you're on mute.
Sorry about that. Yeah, no, I'm going to introduce Leila first. She is Deputy Director of the Centre of Sustainable Cooling at the University of Birmingham. She holds a PhD in Environmental Economics, an MSc in Quantitative Economics, and a BSc in Chemical Engineering. She sits on the Refrigeration, Air Conditioning and Heat Pump Technology Options Committee of the Montreal Protocol and is seconded part-time to the UK Government Department for Energy Security and Net Zero to provide cooling, technical advice and advice to governments, policy strategies and innovation teams responsible for decarbonising the UK energy system. She's also produced several reports on cooling and cold chain needs, the whole system approaches to sustainability, resilient and equitable cooling and cold chain provision, as well as data gathering frameworks and assessment technologies. So Leila, over to you to handle the Q&A.
Thank you, Alan, for the introduction, and a big thank you to IMechE for organising this webinar and having me, and to Tim, of course, for yet another excellent presentation. This is such a vital topic, and I think what makes this work particularly significant is that it's first of its kind to examine the critical role of cooling in both adapting to and mitigating the impacts of rising temperatures and extreme heat from a systems level perspective. But also it offers a pathway for how we can leapfrog to clean cooling solutions that would benefit both the planet and the people. So let's move on to the Q&A. So looking at the broader picture, cooling infrastructure doesn't operate in isolation, but rather as an interconnected network. It's composed of multiple physical systems. So do you feel like that the interdependencies between these subsystems and the overall cooling infrastructure are well understood? And how can we achieve systemic resilience?
Yeah, thanks, Leila. And apologies if I was slurred once or twice during the presentation. I was dealing with all this stuff to do with my injury is a little bit challenging, but hopefully it all came across fine. So yeah, the short answer is no. So you know, there certainly isn't that understanding of those interdependencies. There's a huge amount of work that needs to be done there. that, if you look at the cold chain, there's a much better understanding in the case of the cold chain, because it's more obviously a sort of an integrated system of temperature controlled environment from end to end for temperature sensitive products. And there's been an increase in that understanding, particularly in developing economies like India, for example, where a decade or so ago, simply establishing a cold store was seen as establishing a cold chain, whereas of course there's a huge amount of infrastructure and equipment that goes either side of that and supports that, if you're just thinking about the kit element, let alone the sort of the human resource element. But yeah, there's an increased understanding and a better understanding in the area of cold chains. But as if you look at cooling in its broadest sense, in terms of cooling in the built environment or within the digital domain, or more broadly across industry, then there really is a lack of understanding of the relationship between the components of cooling itself, so how you can link up individual cooling components to have an optimum system, and how you can address and mitigate against any risks of in relation to those interdependencies. There's a real lack of understanding of that and what needs to be done there. So then, of course, if you step back beyond that, there is the entire ecosystem, as you mentioned, Layla, within which cooling sits. So beyond the physical kit, there's the human socio-economic political system within which cooling sits. So that's the elements of economy, policy making, regulatory making activities, natural resources, energy, the technologies and innovation programs, social and cultural dimensions that are all components of the entire cooling system and need to be taken into account when you're looking at interdependencies system-wide. So the report puts a lot of work and effort into this. There is quite a considerable amount in the report about systems thinking, walking the reader through from you're starting with understanding physical systems, interactions and interdependencies, through to the broader ecosystem. And I know, Layla, you've done a lot of work on this yourself.
Yeah, and actually there is a question from the audience kind of feeds into this. Our behavior changes, and they give an example of shift from animal to plant-based proteins, and cultivated protein part of the solution. And I guess behavioral changes are also key to make it work.
Yeah, and we're going to need every single solution we can get. So within this work, of course, we're focusing very strongly on clean cooling as an underpinning solution. But that sits within these place-based and sector-based contexts around a whole wide range of other solutions that we need to reduce the pressure on the cooling infrastructure to deliver everything. So it comes back to that point I made when I was talking about the food production issue and the need for every single gram of food, every calorie of food, every piece of nutrition that we produce to make it through to human consumption. The more we can do to obviously mitigate at that farming and horticulture and aquaculture level before we get into the provision of cooling, the better, because it reduces the demand that we're going to have on cooling. But overall, it's all part of a big system of adaptations that need to take place to enable us to become more resilient.
Thank you. So a question, if you had any thoughts on the way in which low GWP refrigerants will factor into the push for clean cooling, and I think you can also elaborate the concept of thinking thermally, which I kind of related.
Yes. I mean, low GWP is so global warming potential, low global warming potential refrigerants are a key part of the solution. For those in the audience that are not familiar with those, the global warming potential of refrigerants used in refrigerators and air conditioning systems are often very high, in the several thousands, and clearly any leakage that takes place or any spillage of those refrigerants has a out of proportion effect on the global warming compared with what comes from the energy system at that particular moment. So moving towards low GWP is absolutely essential. Of course, we have to be very cognizant while we're doing that we guard against those higher GWPs entering black market scenarios within developed economies and developing economies, and indeed the dumping of equipment that has high GWP into developing economies and least developed economies. So there's a huge ethical, moral, social, economic piece that has to be dealt with there. But broadly, they are clearly a key part of the solution in terms of enabling us to mitigate while simultaneously adapting. And I know, Layla, that you've done a lot of work on that in the past. But of course, stepping back, and you mentioned thinking thermally. So thinking thermally is about trying to take a different approach to cooling right from the start. So not thinking immediately about electrons, and not thinking automatically about getting something and plugging it into the wall and using electricity to provide mechanical cooling. Looking around us for other sources of cooling that are already thermal, so natural cooling, waste cooling that are coming from industrial processes, and utilizing those to store, move, source, move, store, and utilize cooling rather in a sort of end-to-end thermal process, rather than resorting to electricity and batteries. This has a huge advantage in terms of, as I mentioned towards the end of the talk, taking the pressure off new installed renewables to deliver electricity to cooling systems. That electricity can be used for other things, but it also enables us to have a kind of an overall more sustainable and sort of circular economy approach to cooling. And I know, Layla, you yourself have done a lot of work on thermal cooling as well. I mean, there's a lot of work in the report that's come from you on that.
Thank you.
Okay.
So I'm just going to turn to you, Alan. So what do you think of clean cooling? As Tim explained, it takes a much more of a holistic approach. It's sustainable, resilient, and as well as equitable. So how do you think the need for cooling will impact the whole circular economy, given your background?
Well, I think the report's excellent because it really does highlight the challenge we face, because we are getting warmer. Adapting by relocating our cities and food production further north and south presents major challenges and won't happen. And as far as the circular economy goes, I'm just going to explain my view of the circular economy. To me, there are 6 ecologies in the world. One is carbon and greenhouse gases. The other one's the natural world. The other one's material resources, water, atmosphere, and population. And temperature has an impact on all 6 of those. And we need a way of living that addresses by developing a truly global circular economy, which embraces all of the things that Tim's just said. Because if we were just to say we're going to solve this by using billions of the individual cooling units we've got at the present moment, it would be a disaster for the greenhouse gases in the natural world. So we do need to do it in harmony with a circular economy that addresses all of those 6 ecologies. So yeah, I'm really quite impressed, Tim, by your and Layla's work on this.
Thank you. Of course, we should acknowledge Toby Peters and the wider 35 contributors.
Okay, well, we've run out of time, unfortunately. because I'm sure we could have gone on for much longer. So
yeah, probably
you.
we should wrap up.
Yeah.
So anything you would like to say, Tim, before we close?
Yeah, no, I'm conscious of time. I don't want to keep people away from leaving on time. So just really to reiterate the importance of cooling, to point people to the report, to encourage them to dive into the report. It's a huge piece of work. You know, a very big evidence base. Really encourage you to dive into it. But hopefully it's written in a way that's very, very accessible and can provide the sort of the thinking, the fundamental thinking that's required, as well as the individual stats and numbers that are needed to support activity in this area. So really, that's it from me. Thank you very much for giving me that opportunity. Thanks, Leila.
Okay.
Thank you.
The next slide, Tim. So this webinar was supposed to be recorded. It will appear on the IMechE webinar recordings pages. Next slide, Tim. And the next webinar is on safety management framework on the 20th of November. Next slide, Tim. So thank you very much for taking part, and a big thank you to Tim and Leila for doing what they're doing. And if you want a CPT certificate, get in contact with where you're at, and if you click that QR code, which we'll leave up, you can give us some feedback. Thank you very much.
Thank you all.
Thank you.
Thank you.
Tim and Leila, you're going to stay on?
I will be closing the meeting and then we can chat afterwards on our own. Okay. Thank you very much, everybody.